On page 40, we are looking at some area and perimeter formulas. And I did print the inside of these for you. And we're not going to write on the inside. I'm going to do the work around the edges of the page. But I copied this just for myself so I can remember what all it says. But we'll take a look at each of these in I think I'm going to do the area and the perimeter for each one of them. And I thought I would do all of the perimeters and all of the areas, but I think I'm just going to do them by shape. So let's start with the square. If you open the door for the square, you're going to see this information. A square has 360 degrees because it has 4 right angles and 4 equal sides. The formulas that you will need for a square are right there. So let's imagine that this square we're looking at has a side that measures 10 feet. And I'm just making up numbers to plug in here. I will try to keep them to be simple numbers that won't require a whole lot of brain power. So to do the area of the square and the perimeter, you will need the formulas. The perimeter is going to be 4s, and the area is s to the second power. So let's start with perimeter. You just use substitution, where you put a pocket for your letter, and we put a 10. In this case, that's the number I chose. So perimeter is 4 times 10, or 40 feet. Those are linear feet. Perimeter is the distance around. Think of a soldier walking a perimeter, walking around the edge. A perimeter is like a fence. It's the distance around an angular shape. Area is a carpet. It covers. So keywords for area would be cover. For perimeter, it would be the word around. To do the area, we will say an s to the second power. The s is worth 10 in this case. And so that is 10 times 10, which is 100. This is a two-dimensional shape, so it is square feet. We're looking at the number of little squares it would take to cover the surface. You can also write it as 100 feet to the second power. Square feet, either way, is correct. And that's for the square. I think I'm going to do the triangle because it's right here next to that one. For the triangle, the formula for perimeter is side 1 plus side 2 plus side 3. And these subscripts are not to be confused with exponents. Exponents are up at the top. Those are superscripts. These are subscripts, and they're just telling you the lengths of the sides. I think this looks like an isosceles triangle. So let's say that this side is 15 feet, which would mean that this one is also 15 feet. And maybe the base is 10 feet. So to get the perimeter of this triangle, we're going to say side 1, and it doesn't matter which one you start with because you're adding them all. So just add them all up. Perimeter is always involves addition. And this is 40 feet. That's linear feet. One dimensional, so there's no square or anything. It's just plain old feet. The area formula for a triangle is 1/2 the base times the height. Now, you could very easily substitute 0.5 for that half if you want, or you can work with it as a half. So we plug in the pockets. The 1/2 is constant, so you don't put a pocket for it. The base of this triangle is 10, but be careful. The height is not 15. Your doctor would never measure your height unless you're standing up straight. So we need to know the height of this triangle as this imaginary line from the base to the point. And I'm going to say that it's about 12 feet. Again, I'm just making up numbers here. But the height is 12. The 15s don't factor into this problem. So area is 1/2 of 10 times 12. That's 120. So this is the same as saying 1 times 120 over 2. The area of this triangle is 60 feet squared, or 60 square feet. Area is always square units. As the shape gets complicated, the formula gets complicated. All right, let's do the trapezoid. I love these, even though they are a little complicated. A trapezoid, if you look at your information, is right here. The formula for the trapezoid is pretty complicated. The perimeter formula is just adding up the sides, but the area formula is a little bit tricky. So let's give it some dimension. I'm going to let this top line be, let's use inches this time. And maybe this one is 15 inches. And maybe each of these is 9. We need to know the height. The height is perpendicular to the base, so you may see a little right angle in there. And I think I'm going to let the height be 11 on this one. Okay, so this is the trapezoid. The perimeter is side 1 plus side 2 plus side 3 plus side 4. If you want the soldier to walk the perimeter, he's going to walk around the sides. So I put in a pocket for each of those variables. And it doesn't matter because you're adding them up. Just put all of the sides in there. The 11 is not a side. It's an imaginary line on the inside, so you would not count it. So perimeter is, I'm just going to use my calculator. I'm very tired at this point, and I will make mistakes. I make mistakes when I'm not tired. So 43 inches around the shape. And let's not do that. I need a little more space. I think my pen's running low on battery power. All right, the area of a trapezoid is going to be 1/2 base 1 plus base 2 times height. So area is going to be 1/2. We already have pockets here, so I'm just going to leave those. I am going to put a pocket for H. H is 11 in my example. The bases here are 10 and 15. And you must follow the order of operations. So you have to do parentheses first. So we're going to do the parentheses to get 25. And then copy. Then 1/2 of 25 times 11. And you can use 0.5 there. 25 times 11 times 0.5. That'll work. Or you can say 275 divided by 2. That would be 137.5 square feet, square inches. Or you can write it as 137.5 square inches. And I used up a lot of space for the trapezoid. Let me go ahead and let me move this up just a little bit more because I don't want to run out of room here. That is your trapezoid. All right, let's go over and do an easier one. This is the rectangle. This is probably the simplest one. Even to me, the square is not quite this simple. But we have a width that will be maybe 8 meters. That looks like a variable. So and then maybe our length is going to be 15. Okay, so the formula for this one, for perimeter, is 2 L's plus 2 W's. So put your pockets in. Length is 15. Width is 8. Follow the order of operations. So you have 30 plus 16. So this perimeter is 46 meters. And then the area, I'm just going to squeeze in right here. The area for a rectangle is length times width. So 15 times 8 will give you your area. And that is 120 square units, which in this case is meters, or 120 meters squared. The next one is called a rhombus. It's this one right here. I have never in my life had to find the area of a rhombus. So I gave you the formula, but I'm not going to do that one. I am going to show you the perimeter for a rhombus. Because a rhombus has equal sides. These tick marks mean that the sides are all the same. So, a couple of ways you can do it. You could use the one for a square. You could just do 4s. The one I gave you, I really wanted to just practice this notation. Make sure you really have a good grounding in this one. So if the rhombus has a side, let's use 6 centimeters. and it's congruent on all sides, you're just going to be adding up the sides. This will always work for perimeter. Sometimes there's an easier way, like on this one there is, and I'll show you. 24 centimeters. You could also have just said perimeter is 4 times the side because the sides are equal. So perimeter is 4 times 6. The perimeter is 24 centimeters. Either formula will work. That's a rhombus. And the rhombus's neighbor is the parallelogram. I am going to do area on this one because sometimes you do see this one. So let's give it a height. Maybe the height is 5. What have I not used? We've used feet, we've used inches, we've used meters, centimeters. Let's do kilometers. And maybe this longest side is 12 kilometers. And this wide side is about 6 kilometers. So to get the perimeter of a parallelogram, you can use the same formula that you did for a rectangle, because we have 2 of the long sides and 2 of the wide sides. The height is inside, so it's not going to count in this fence that goes around. There's 24 plus 12. So perimeter for this given one is 36 kilometers. The area for a parallelogram is base times height. Base times height is 12 times 5. So that's 60 square kilometers, or 60 kilometers squared. This one is a regular hexagon. If you have a regular shape, that means that all of the sides are the same length. This one, the rhombus, is regular. The square is regular. Sometimes triangles are, but this particular one is not. An equilateral triangle is regular. But this hexagon is regular. So when you have something regular, you can simply say, to get the perimeter, that it's the number of sides, in this case 6, times the side. So if we said that one side is maybe let's do 5 feet. To find the perimeter, you could add them, or you can just say 6 times 5. And that would be 30 of those units. I am not going to do the area of a hexagon. I don't think I even gave it to you, simply because I don't know the area formula for a hexagon. I've never used it. All right, a pentagon. In this case, I don't think it's regular. It might be if we measured it. I think maybe these two are the same. These two are the same. And possibly this one matches up there. I just am not sure, but that's what we'll pretend. So let's say that this is 4 inches and this is 6 inches. And maybe that's all they give me. But I know how to read those tick marks. All of the single ones would match. And then this one is going to be matching up with that other one. That's a double. And to get your perimeter, you simply add up your sides. So I'm going to say any pentagon has 5 sides. You can probably figure this in the time it takes me to write it. There's 4 plus 4 plus 6 plus 4 plus 6. So I'm thinking 24 inches. Let me calculate that. That's 4 and 4 is 8, plus 6 is 14, 18, 24. Okay. All right. This one looks like it's probably regular. So we're going to pretend that it is, meaning that all of the sides are the same. This is a heptagon. And as long as it's regular, we can just count the sides. There are 7 of them. And multiply it. So maybe this is 2 miles. It looks like a trampoline. Let's do that instead. Instead of miles, let's make this thing a trampoline. So let's say 12 feet. It's a big trampoline. All right, so we're going to say perimeter is 7 times 12. So perimeter is 84 feet. And then our last one is a stop sign. It's an octagon. So I'm going to make it regular. I used to know how many inches these sides were. I can't remember. But on this one, I'm going to use a fraction this time, just in case you should run across that. Let's say that this is 9/10 of a foot. It is regular, so we can use the shortcut. An octagon has 8 sides, so the perimeter is 8 times the side. And that is 8 times 9/10. You can think of this as 8 over 1 times 9 over 10. Top times top. Bottom times bottom. And then go ahead and simplify. 7.2 feet. So you can absolutely have fractions in these formulas. Goodness, that was a lot. But this is every shape that I have ever seen on a test, and I think you are likely to not see anything but a square, a triangle, and a rectangle. However, I do not know. So just in case, I wanted to show you how to do those.